Hey guys, it's Andy here, and in this video I'm going to just show you how I built my charging station for 18650 batteries. I'd say over 90% of all videos on the internet of how to build your own charging station are absolute garbage. Absolute garbage. It's like building a Lego set. The instruction manual did that for you. Why'd you have to make a video about it? So in this video I'm going to talk about some issues and some things you might want to try and use when building your charging station. First, we're going to go through the easy things, the Opus and the Lithium-ion and the HW. I do recommend leaving your chargers, like putting them on the wall and making them face positive side up. Now for these units, it's on the wall. I mounted it using slotted method. So I drilled holes and then one big hole. I used these screws here. Okay, they're 4x1s, and this pack of 124 of them was like $7 Canadian. For the 4x1 screws, I use this adapter to go on my impact, and I've had to use a grinder several times to make it work properly, unfortunately. And I got it out of this kit. I think I paid $15 for this kit. Works good, but you might want to invest in a much better drill bit. I've got this this little wood frame built, and it's been a lot of rough work just measuring and cutting out. All of these are universally able to be pulled out. So I've improved on that design by cutting out my own notches. They're very rough, but no one's ever going to see it, and then I can tighten down the screws through there. But this one here, this module, will have to be perfect from the start, so that's why I take this guy off, I put him down. And what I did to make them all universal, since the Opus is very different, is all I did was I took one of these guys out and I put him there, and then I measured it up as if a Lita Kai would be here. And then I just, made it so that this one would fit. You'll see these lines. This is inside there. You'll see just before these lines here, you drill a hole, and then up as high as you can, you drill a hole. And you do that only on the left and right one. I highly recommend taking off the back plate, taking off the 6 screws. That way you don't hit the circuit board or wreck anything, right? Or hit the rails, because you can easily damage these rails. They're very thin, very thin. So you just drill a whole bunch of small holes, and then you just kind of slowly work your way back and forth, and you eventually make it a straight line, and then you use a razor blade or a box cutting knife of some kind and smooth it out a bit. You have to drill one hole that's slightly bigger than the head of these screws. The nice thing about the Lithium-ion is where you want the screw to end up, you can just put these down, drill a hole, take it off, and then continue drilling the hole out, and then put the screw in, and then it just kind of goes in and slides up. You can also tighten down the screws through these holes. These parts here, these 4 points, even on the Lolito Kais, they're very weak. I had to put hot glue all over them because they just shattered. I've taken apart my Opus so many different times that it just breaks these plastic points, so I reinforced them with hot glue, and that should be fine. These units all go up to this buck converter here. Now the bottom end, these bottom ones, they just go in the back, and then just like this one is done, I use this stuff here. It just comes in a big coil, and I use it to hold down all the loose wire, and then I drilled 3 holes right here and just ran the wire up and through, and then I bundled them all together. I soldered all the red, like all the positives together and all the negatives to each other, and then put it in, since it's next to impossible to fit this many wires onto these really crappy terminal blocks. The HW here, I put it on here because I have it. That's the only reason. And I have it hooked up down here and up to this slot here. So I have this selector switch. It's a on, off, on, double pull, double throw switch, and it'll be linked in the description where I got it from. They're pretty good, and the nice thing is you can drill a hole and you've got this nice screw. This was another option I had, was these. These look much nicer. I like them more, but they're harder to mount. You have to do a lot of finagling to mount these units. I secured the selector switch using a metal bracket used for putting mirrors on walls, a lot like this. It's normally a straight piece. This one was bent in the opposite direction. I used really strong side cutters to trim up and bend this little hook piece here so that it would rest on the lip of this battery holder to give it a little bit of extra strength, and then I used a lot of hot glue to further strengthen it, and it seems to be just fine like that, no issues. Then you just have to kind of eye it up and then drill your hole so that your selector switch can go through the bracket. I just use whatever I find lying around. I don't try to make things fancy or complicated. Hooked up to this unit here, only this one. If this switch is selected up is charging through the TP4056 right here, right? And then middle, the battery is not connected to anything. And then down position, the battery is connected to the HW. I use this small switch right here, and it's soldered onto this heat sink, and there's a heat sink on the back of it, and then the two resistors are sandwiched in between with thermal paste, and then there's zip ties, and there's a ton of hot glue everywhere. I have the selector switch to go from one resistor to two in parallel. Now 2 in series gives you about 100 to 200 milliamp hour higher reading because it's slower discharge. But the 2 in parallel gives you 4 times faster results, and I think is more real world. So I prefer 2 in parallel, but I can do 1 in series with the selector switch, which is really nice. The really nice thing about this HW is you can select the minimal voltage that it discharges to, which is extremely valuable, and I can do any battery type on these units. So I can go anything from, what is it, 15 or 16 volts all the way down to 0 volts to discharge, which is really cool. So that's a really nice thing it has going for. Unfortunately, it has no safety feature, has no thermal shutoff safeties, nothing like that. You can't even charge them, so you need a TP4056 to charge up the battery, and you need a holder. Consider those variables if you want these units. I have this old computer fan hooked up, and it has a selector on-off switch. It's very tiny single pole double throw switches soldered right onto the circuit board of the fan. The reason it's mandatory is not just for the heat sink of this HW, but the Lolito Kai gets very hot and the batteries get very hot. It has no fan of its own. That's why this fan is here pushing air this way. And it's just mounted with random brackets I found lying around. So that being said, let's move on to this unit. It was built in layers. I have this corrugated plastic. It's very handy to have. It's a little pricey, in my opinion, for what it is, but so you put one layer down and it raises the whole unit up high enough so that these pins are not digging into the drywall behind it. It'll also give you channels that you can run your wire through safely back down to your TP4056. Now, I hot glue gunned the TP4056s down. Now, there's a little trick to it, a mistake I made. You have to hot glue the center of each TP4056. I did the corners, and that caused trouble. I couldn't run my wire through because there's hot glue sticking up out of there. I was able to line up the negative of the TP46 with the negative of the battery holder and solder directly on like this. Okay, so and then the positive, I ran the wire from there through the channel of the corrugated plastic, out and then down and in. It's a little tricky, but it works. In the 4 corners of each holder, I put these 4x1s, and they go through and through the drywall and into the back wood. I was working very late, very tired, not thinking straight. I grabbed the wrong transformer and I popcorned all of the TP4056s. It's only an $8 mistake. Here's one thing I need to ask you guys. Now, the green light is on and the red light is flashing on these two units. Does that mean that it's broken? Or there's an error? Or does it mean that there's just no battery in there? If I put a battery in, it doesn't flash. So I'm just curious if that flashing light means that, is that normal? If you do know, please leave me a comment. Once my other TP4056 chips come in, I can put in 2 more holders. That's why there's this big space here. The buck converters, they have a max of 20 amps and a regular of 15 amps. Now these units up here are going to consume somewhere around 19.2 amps at 5 volts. So that's pushing it right to the edge, and we'll see if this guy can handle that. I'm curious how long or how well it can handle that kind of load, because 5 volts is pretty low. This thing can do up to 36 volts, I believe. If you put it at a low voltage, it can handle a higher amperage. We'll find out. That'll be interesting to see, and I'll keep you guys updated on that, but it may take a month or 2 before I'll find out for certain. These little voltmeters, they come in these anti-static bags when you buy them. Very simple. The wire that comes with it is garbage. It's very, very fragile, so you either be very careful with it or you immediately solder it off and put on some better wire. One thing that I will definitely have to do is put a fuse right here. I'm gonna have to decide what kind of fuse I need to put. I think the best thing to do is to use a cigarette lighter, that way I don't reverse polarity, because diodes are not advisable. They heat up and they waste energy, and since I'm going to be running my charging station off my power wall over there, I'm going to have to try to be as efficient as possible. The last thing I want to talk about is the drywall backing that I put on these. Of anything that could go wrong in your off-grid system, it's going to be one of these charging stations, or your batteries will catch fire while they're being charged. But this is the most likely place that a fire will occur. These guys have a temperature shut off for safety, but this doesn't, and that's a huge problem. So you're going to want drywall. This is pretty thick, too thick arguably. There's stuff that's half as thick as this that you can get your hands on. It's used for fine house modeling work, where they're doing curved walls, fancy stuff. I used to do drywall work, but anyways, you can get a hold of much thinner stuff, which I'd highly recommend, because this is so thick that my 4x1 screws just barely dig into the wood behind it. Now, drywall is incredibly underrated. People just don't realize how important drywall is and how much protection drywall gives you. This shelf here has drywall on it. So if this catches fire, heat is absorbed by the drywall up here and behind it as well. And I'm going to put a piece of drywall right here. So you see in this picture right now, there was drywall right above a fire in a wood stove room. So the fire was right below it. And where the black is, that's where there was no drywall. And where you see, like, it looks like brand new plywood, the drywall is there, and it shrank like 20% because there's so much moisture in it, but there was no damage, even though the flames were right on top of that area. Now the wall right beside it, it was completely burned out. It had to be completely replaced. So this is a testament to why drywall is so incredibly important, especially with these TP4056s. You're testing batteries, you're charging them up. You don't know if they're safe to charge up or not, so you have to charge them up first to try out. Well, it could catch fire. If you have any suggestions, any comments, any questions at all, please feel free to ask. There's no such thing as a dumb question. This is not simple stuff, so it's better to ask than to make a big mistake and possibly burn down your house, right? So I hope you liked the video. I hope you found it interesting and useful. I find there's a lot of videos that all about making your own charging and testing station, and they have absolutely no context. They don't teach you anything. They don't explain anything to you. I have a lot of videos coming up in the future. One of them will be fuse testing using this hair dryer. I got the idea from Average Joe, so you can check out his channel and check out his video he did using a hair dryer to fuse test. Really smart, so I'm going to try that out and do some testing applicable to my units, especially for these two guys on the output and the input. I'll also be putting out a video soon comparing the HW586 to the LII500 to the Opus. Now, a few guys like Steve have already given me a bit of information on different chargers and issues they've had with their Opus and other chargers that they have. So any information you have or issues you've come across with your units, it would be greatly appreciated, so I can put that in the video and help other people out in deciding. Now, unfortunately, there's some issues in Canada especially, so these are my financially viable options, so I'm going to stick to these ones, but there are other units, I just don't know of their quality compared to these. I also have videos coming out of me building my own solar charger in the future and using different cheap MPPTs and see how that works. And I have a video coming out, hopefully eventually, of completely converting a desktop gaming computer to run straight off of the power pack here rather than going through an inverter and a PSU. Look for those, and if you have any suggestions or advice, that's always greatly appreciated. Thanks again for watching, and have a great day. Bye. Heard some grunting in the background. I'm not sure if I'll be able to cut it out, but yeah, I've got a baby squirrel. He's maybe 3 weeks old, but he still needs milk, and he can't really eat very much on his own, but I imagine in a week or two he will. He mostly just sleeps all the time. I was working outside in my front yard and I heard this grunting noise and I saw this guy crawling towards me. He kind of chose me as more of a rescue than a pet, because I plan on releasing him as soon as he's capable. Not that we need more black squirrels in the neighborhood, but I don't see too many black squirrels anyways where I live, so it's not like it's a problem. My daughter named him Summer. It's a pretty cute name. He's always climbing around on me and pretty easy to take care of. Pretty easy pet. At most, he grunts, and if you leave him alone too long, he'll start squeaking or chirping to try and get you to come over, and as soon as you start talking or walk over, he immediately stops chirping, which is pretty cute. What do you got, Addie?
Oh, it's a gold some teeth.
Yeah.
And then when they're that young, they don't have the fear.
No. Hey, Addie, turn this way. He lives in this home I built for him. So my daughter and I, we put this together. It's just 2 different ice cream pails and then connected with some dowel tubing. And it's just use hot glue, because eventually this will go outside. That's why it's got this little sun and rain reflector. It's just a piece of garbage plastic. So he seems to like it. He likes hanging out in there. And it's got a cardboard box inside there with a lot of shredded tissue paper. And I got some of this cotton balls that he can put in there too. And that should make a pretty good little home for him.